Okay, we're live, ladies and gentlemen. We are live for another study session. Yoo-hoo! What am I going to do today? Today, I'm going to watch a little bit of the resources from Jim's GAMSAT, like we did before, and then I'm going to try some practice questions from section 3 and just go from there. Today I did a bit of like a tiny little bit of study off stream and felt like I made a bit of progress, like in terms of defining the excuse me, defining the question that I've been working on. Um, it's when I say a little bit of progress, I really mean a little tiny bit. So I'll look at that as well. But yeah, so I'll just go from the Jim's GameSat resources stuff first, and then we'll work our way into some questions. Let me just set myself up here. Probably gonna do about an hour, 45 to an hour tonight, and then we'll pick it back up tomorrow morning, perhaps. We'll see. Where are we up? Yeah, so we'll just finish maybe these two, and then I'll see what the next bit of content is. If it's like skill acquisition, so like building the math skills and stuff like that, I probably won't do that yet. I'll go straight into the questions. But I'll just finish this off, which should be about, we'll see the length is 22 minutes, and then this one's 15. Yeah, so we'll finish these off and then perhaps jump into some questions.
Okay, so next up we have abstract reasoning, which is where we're trying to interpret, generalize, and apply patterns. So I think this is particularly common in chemistry. I think it lends itself very well because if you think about the properties of a molecule, it's very predictable how they change. So if you can, it lends itself very well to extrapolating that pattern and applying it to new molecules that you haven't seen before. The other way they use it is with reactions, because again, if something reacts in one way, if you make that molecule bigger or smaller, it should still react the same way. So again, we're trying to extrapolate those patterns. So in this video, I'm going to show you a couple of ways I see abstract reasoning present itself, but as I say, very common in chemistry. And I think if you just keep an eye out in these chemistry questions for potential patterns, that's very useful. So we'll start with this question here, which is asking about the boiling point of these molecules broadly. And you can see that we've got a table there, and I would be looking at this table and just thinking this definitely lends itself well to a pattern, because look how similar a lot of these molecules are. We've got all these different things, and it kind of shows us the pattern of adding chlorine groups and adding carbons in these molecules. So we can definitely try to draw patterns. Now, when I'm looking for patterns, I'm always trying to keep as much constant as possible and just think, would anything change the way this pattern behaves? So it behaves like this for these ones, but is there anything else that might have an interaction with that pattern? The combination of patterns, if you will. So let's just put that into effect, and we'll try work through this question here. So which of the following is most likely to have a boiling point closest to 57 degrees?
So, yeah, so basically what I did today, the little tiny bit of progress I made was I think I found well, the other session I was just a little interlude here. I was trying to work on the first question of section 3, and I was spending a lot of time on it. Even though I knew the answer because I'd looked at the answer, I didn't know how to reason my way to it and use the skills to get my way to it. But I think today I found out why the answer is the answer, and that came from defining the question correctly. Now, I don't think the reason why it's only a tiny bit of progress is because I think I wouldn't have been able to define the question correctly without knowing the answer to the question in the first place. So, again, so it's a tiny bit of progress, but still progress. So, for this, I think I'm going to stick with, working on defining the question. Um, and maybe I'll show you after these videos, what I came to as like a conclusion in the defining the question part, for the first question in section 3. So I'll do as I go through the video. I will do that here and have a look and see what I can do. So which of the following is most likely to have a boiling point closest to 57 degrees? Okay, so they want the boiling point closest to 57 degrees. Okay. Okay, so how are we defining the question? So I'm guessing they're going to give us some parameters and stuff like that. So let's maybe have a look through the information first. Okay, so what have we got here? We've got some, I don't know what these are. Molecules, maybe? So we've got molecules and their boiling points. So let's look at the stem.
So my first step would be to find something that's similar to this 3-chlorobutane. So the
Okay, so molecule boiling point. Okay, so we're given ethane, chloroethane, propane, chloropropane. Okay, any of those? So none of those are actually in the molecule list. So we're gonna have to some type of reasoning to get the boiling point. And I imagine there's going to be some basic chemistry skill slash knowledge that we're going to need to have to answer this question. So depending on whether I have that knowledge or not, I'm going to be able to answer this question, and whether I'm able to define the question well enough to reason my way to that answer. So we'll see. So, okay, so 57 degrees I believe was the boiling point. So 89, 12, 42, 46. So out of these, 46 is the closest. That's 1-chloropropane. So at this stage, that's my answer. Is, I don't know, 3. Well, okay, so we're working with 1-chloropropane at the moment because that's the closest. So we'll see what more information we can get.
first thing that pops into my head is 1-chlorobutane.
So the reason I think is because that's the answer here. So 3-chlorobutane. So that would be 78. So we don't know what 3-chlorobutane is, but
And I'll be trying to think, well, okay, I've got 1-chlorobutane. So what do I need to do? I need to see the effect of going from 1 to 2.
that's not 2 though, is it? Chlorobromobutane?
And then from 2 to 3. Now, where could I find that data? Well, if I look at these propane molecules,
So 1 to 2-chlorobutane, it actually, as we go, as we add a chloropropane, the boiling point drops by, what, 11 degrees?
I can actually see that that shows me from 1 to 2. And then surely from that, I can extrapolate what 1 to 2 and from 2 to 3 would be. So if I go from 1 to 2, this is minus 11. So surely if I'm minus to 3, it should be around minus 11 as well. At least is a good starting point. So if I apply that, so we've got 78. So if we go from 2 to 3, that'll be, so 1 to 2, that'll be.
Okay, so if we go chlorobutane, and we start with 78, and then 2-chlorobutane is 67, 3-chlorobutane is 56. That's pretty damn close.
Be minus 11. And then from 2 to 3, that'll be minus 11 as well, which will be a total of minus 22. So if we do that with our 78 minus 22, that will give us 56. So looks pretty good. But have we maybe fallen for confirmation bias? Maybe, because we have just assumed that everything that they've told us is correct. So this is what I mean with the confirmation bias is you always want to be looking for that deductive reasoning just to see have you fallen for a trap. And what the trap is here is actually this 3-chlorobutane. So if I drew that out, we'd put a chlorine on the third carbon, and that would mean 1, 2, 3, 4. So I haven't done the hydrogen, but you can see what I'm getting at. Now, when we're naming molecules, we can actually start this counting from the other side, can't we? And we would count it from that side because we want to minimize the number of the functional group, which in this case is chlorine. So, again, this is why deductive reasoning is so important because you really want to be validating every single conclusion that you're making. And it just helps if you're just aware of deductive reasoning as a process.
Yeah, so I guess the reason why one would make a mistake here, including me, is that I didn't understand what the 3 meant in chlorobutane, for example. So now I've come to understand that the 3 is the chlorine on the third carbon, I believe. But we'll see.
To think, okay, if I'm making this conclusion, these premises need to be true. So if I'm making the conclusion that going from 1 to 2 and 2 to 3 is like that, I need to make sure that I am actually going from 1 to 2 and 2 to 3, and 3-chlorobutane actually doesn't exist. So this one would actually be the same as 2-chlorobutane because that's the same molecule. So this one would actually have a boiling point closer to 67. Okay, looking at the next molecule, so 1,1-dichloroethane. So again, I'm looking for the molecule closest to what I have.
Okay, so dichloroethane. I have chloroethane. So that's 12. So 1,1-dichloroethane. Imagine that's just 2-chloroethane. I don't really know, but and then 1,1. The carbon is on the first. The chlorine is on the first carbon, maybe. So that's 12. Hmm. I wouldn't know where to go from here.
And I have chloroethane here, which looks pretty good. So what I need is the effect of adding another chlorine. Now,
we have that.
Now, if I look through the table, I don't have a dichloro, so I can't generalize that anywhere else. But I can see here that I've got a chlorobromobutane. And if I actually compare that to the molecule above, it's actually exactly the same. Because remember, if we have something, a functional group on the first carbon, we don't write 1. So this is essentially 1,1-chlorobromobutane. So the only thing that I've changed here is actually added a second bromine to the first carbon of a butane molecule. Everything else is exactly the same. So if I compare these two, that's just showing me the effect of adding a second bromine.
You've lost me.
Now we're closest to what I have, and I have chloroethane here, which looks pretty good. So what I need is the effect of adding another chlorine. Now, if I look through the table, I don't have a dichloro, so I can't generalize that anywhere else. But I can see here that I've got a chlorobromo butane.
I don't understand how that helps.
And if I actually compare that to the molecule above, it's actually exactly the same. Because remember, if we have something, a functional group on the first carbon, we don't write 1. So this is essentially 1,1 chlorobromobutane. So the only thing that I've changed here is actually added a second bromine to the first carbon of a
But it's not butane, it's ethane. So it's confusing me.
butane molecule. Everything else is exactly the
Maybe
same.
we
So
can
if
just
I
ignore
compare
that.
these two, that's just showing me the effect of adding a second bromine. Now, again, we need to use that deductive reasoning to say, well, is bromine the same as chlorine? So we could go up and find our information, and it says this gives boiling points for various haloalkanes, and it's showing the effect of methyl and halide addition. Now, if it's saying halides as a group, you don't need to know explicitly what halides mean, but you've probably seen it pop up enough times that you know it has something to do
Never
with
seen it in my life.
bromines, chlorines, fluorines, all of that. So I would say, based on this, grouping them together as the addition of halide, it would be fair to conclude that chlorine and bromine would have a similar effect, because otherwise
So I guess that's the
they would split them
knowledge,
apart. So the
initial
fact that
knowledge
they're
that I'm
grouped
missing.
together as halide addition, I think, supports the conclusion that chlorine and bromine would have a similar effect, and therefore we can determine the effect of adding a second halide onto the first carbon.
So I think what I'll do is in my notes here, I'll write I'll just write those little like knowledge. I'll come up with a knowledge bank. Knowledge bank. This can be just information that's useful to the GAMSAT. So we'll go on chemistry. And we'll go halide. What is that? I don't know if this is like worth my time, but I mean, I guess it is because if I don't know this, I guess I can't answer that question. So may as well try and store it somewhere.
in a butane molecule from comparing these molecules. So let's do that. So we've got 78 to 113, so that's about plus 35. Now, we could then say, okay, well, we could then do plus 35 on the chloroethane. But again, we need to make sure that our pattern holds up for all the different variables, because all we've seen is it's plus 35 in butane. So, would it be the same in propane or ethane? I'm not sure. So let's have a look and see if we could validate that. So if I'm thinking, is the effect of adding chlorine molecules the same in ethane, propane, and butane? Well, I could look at the effect of going from ethane to chloroethane, and this is plus 101. Now, if it was the same in propane, when I compare these two, propane and chloropropane, that should be 101. And if I look at it, it's actually going only plus 88. So, and we can see, we could find what butane is, but we can already see that the effect is getting lesser as we go on. So we know those effects. So let's rub that out to keep things clean, because otherwise it's going to be a rainbow on here. So let's just see what
The rainbow in my mind
let's
right
just
now.
see what butane would be. So if we go from ethane to propane now, negative 89 to negative 42. So this is like plus 47. Now, as we can see the effect of chlorines diminishing as we increase the carbons, I would say it's probably fair to conclude that the effect of adding carbons is probably going to diminish as we go as well. So again, that's your deductive reasoning. So that it really does underlie all of our reasoning processes. So I would probably say that butane, I'm just going to say that it could be 0, because it maybe be plus 42 based on this trend of decreasing as we add more carbon. So you have to be comfortable making these assumptions, but I think that it's valid to say that it also just makes sense. You know that things don't change the same way as you go down the periodic table. It kind of has these peaks and troughs. So I think that would be a reasonable conclusion to draw. Now, I know there's a lot of steps, but this is why I made this question this way, is to really put you to the test in how you can test all these patterns and see the effect of adding things. So this is your abstract reasoning. So now if I compare butane to 1-chlorobutane, we can see that we go up plus 78. So the reason I did that is so I can see the effect of adding chlorine in ethane, propane, and butane. And we can see that that diminishes slightly everything down. Now, this is going down, maybe, well, what is that, 13? And then from here, it's negative 10. So if we start looking at that in terms of this 35, we can't really we can't just say, well, it'll be plus 10 and plus 13, because if we look at those numbers, they're in the hundreds. And this is 180, 78, and then it's plus 35. So it's around half. So I would say that a fair pattern to draw would be half of the effect that we see in this diminishing thing, I would say, because that would be the same percentage increase. I hope that's making sense. So basically, I've extrapolated the pattern of adding chlorines, just single chlorines, and I can see that that's diminishing. And I've almost taken that, rather than an absolute number, I've taken it as a percentage, and I'm going to halve that percentage, because in butane, instead of plus 78, we've got plus 35, which is roughly half. So I'm going to say that this would be about plus 5. This would be about plus 8. So it'd mean that adding a second chlorine, remember that's what this plus 35 means. This plus 35 was the very first number that we got from comparing 1-chlorobutane butane to chlorobromobutane. So that would mean that if we added a second chlorine on the first carbon in propane, it should be plus 40-ish. And then in so in ethane now, we need to add on about 8. Actually, I've done that a bit much. Should be about plus 6, sorry, because we're halving 13. So that'll be about plus 46. So as we go from 12 plus 46, it takes us to 58. So I would say that 1,1-dichloroethane would be about 58. Now that was obviously very complicated, but I think this is the point of why I made this question, is just showing you that you can extrapolate patterns, but then also see how patterns change when another variable changes. So what we can take away from that process, I'll just bring that all up again, is we want to look at things in isolation, then look at something else in isolation, and then also look at them together to get the overwhelming underlying pattern. But what we have is 1,1-dichloroethane would be about 58 based on all those patterns that we have. Just tidied everything up a little bit. So now we have pentane. So again, we got butane before, which we said was about 0. So let's just see how we got that. Remember, we compared ethane to propane, which was about plus 47. And then we said it diminishes as we add more carbon. So that's why we said plus 42. So that's going to diminish again, which would be about plus, let's just say, 36 or something like that. That would be pentane. So pentane would be about 36. So that would be wrong.
I'm wondering, do you have to
A
know
is
these
also not
molecules?
supported.
Because I just don't. Like,
That would be pentane. So
there's no pentane. I don't know, like, what like atoms and stuff these molecules contain. So there's no way I'm answering this question.
pentane would be about 36. So that would be wrong. A is also not supported either. And then there's chloropropane.
It's propane 42, chloropropane 46.
Now, if we look at it, we've actually got one chloropropane already. And we know that chloropropane is the same as one chloropropane. So that will literally be 46. So quite an easy one. So
Do we know that?
again, what I want
didn't.
you to take away from that is how we can look at patterns in isolation and also then combine that with other patterns to see how patterns change as other variables change as well. Okay, and here's another question that you can kind of just...
I just got super tired all of a sudden, so I'm actually just gonna leave it here. A little half an hour, little quick half an hour session. So I'm happy with that. We'll leave it here, and I'll pick it up tomorrow, bright and early tomorrow morning. So join the stream then. See ya, everyone.